Second, so I was here on Monday, and then I didn't realize we use the same GoToMeeting ID, so I wasn't able to join yesterday, but that's why I joined today.
Okay, that's okay. We had some discussion about the ER modeling and other kind of modeling stuff, we started discussing yesterday. So I'll be just moving into the dimensional modeling today, so that yeah. I hope it is okay for you.
Yeah, perfect.
Yeah.
Do you guys keep recordings of the meetings anywhere or no?
Yes, I think the organizers do that. You can also get the copy of the meeting from the organizers, yes.
Okay, I'll reach out to them and see if they can provide that.
Yes.
I got the email and I got the link for the Dropbox. I went through some of the slides, PowerPoint presentation, not all of them, but I mean, yes, thank you very much for that.
Yeah, that's okay. You're welcome. Okay, so I just wanted to, talk about multidimensional modeling today, a little bit, the basics, so that we can move on to, HANA modeling. We try to, see the HANA terminology of the multidimensional modeling. First, we try to talk about the general concepts of the multidimensional modeling. Of course, the same thing is going to be in the SAP HANA, the terminology, the way how we call, and a little bit difference would be there. So I feel it is better we start from the standard multidimensional modeling right now. So I wanted to ask you the difference between the master data and metadata here. I want to remind, in fact, the first step, because we quite often use this, the master data and the metadata. So the example I was trying to give here is metadata is obviously like, the table name, and yeah, please go ahead.
I'm sorry.
Yeah, I was just trying to, remind you guys about the master data versus metadata, because we're going to use it quite often once we, got into HANA Studio and other modeling, other stuff. So the difference would be always, what is the master data and metadata? I think we all know that. Just could be a silly question for some people.
That is something that there is like permanent type of thing. We cannot change it frequently.
Okay.
And the metadata is the data about the data, the details of the data.
For example, if I have a table like this, then
like we have a table like customer name, customer ID, customer account number. So and the table has the content, like for each customer there is a customer ID. So that table, customer address, customer name, so that table is master data. But the header, like if we have a table with only the heading, the customer ID, customer number, customer name, but there is no content in there, so that will be metadata.
Correct. Yes. I think we all clear on that. Yes. Is it okay, Kamran? Yeah, because the point is here, what she's trying to say is the table.
Sir, screen is not coming.
Okay, sorry, I did not put the screen. Yeah, thank you.
No, yeah.
Right now, can you see? Yeah. We're actually trying to see, in a given table, two-dimensional modeling view on a table. We will only talk about in terms of tables here, because that's what the relational database, we talk about only in terms of tables when we do two-dimensional modeling, at the same time when we do multi-dimensional modeling, all in terms of tables and views. We spoke about the difference between a table, a physical table, and a view. So right now, I just wanted to remind you about the master data and the metadata. Just now, as Aruna said, it's the same thing. The table, obviously, the owner of the table name, and then column names, and the data type of the columns, and probably where the table information would have come. All these things are metadata, and the content inside the table is nothing but the master data. These content things are going to be master data. Is that okay? And then I just move on to this concept again. I just wanted to a little bit emphasize on the data warehouse basics first, because this is okay. The definitions and all this, you can get it from the slides. You can just go through my slides and get it. But in general, if I ask you the fundamental difference between data warehouse and databases, so what would be your answer? Data warehouse. Obviously, we consider data warehouse is much bigger than the database, and it has it is actually denormalized in nature, and the main thing is the structures in the data warehouse are multidimensional when compared to the structures in the database, which are two-dimensional. So this is the fundamental point. The design aspect is different. So when we design a database, we focus on designing two-dimensional structures, which means the table versus the table in a join conditions. We have various joins. We try to relate one table with the other table by bringing the joins, and then more number of tables, more number of joins. So the structure gets complicated, but it is still two-dimensional. In the complex environment of the transactional system, still the structure could be complex, but still two-dimensional. But here we try to move on to the multidimensional. So there are so many other differences. You can just get it from my slides. This is a fundamental theory behind the data warehouses. It is better if you understand, if you go through and if you Google it more on data warehouses versus database. It's always good, because essentially in HANA, we will treat HANA as not only RDBMS, we will also treat as a basis for the construction of the data warehousing modeling artifacts, which are multidimensional artifacts. So that is what we're going to see today. And yeah, if you see this in data warehouse, we actually we do the data migration, obviously, because always we assume that the data is going to be at the database side. So what happens is we could be having several databases, could be more than one system, and then the idea is to bring all these databases into a warehouse. So it's nothing but a warehouse of databases. The data warehouse does it that way. So this is nothing but a warehouse of databases. So how do we do that? We do that in we use something called ETL for that. We will also see ETL also includes in the SAP HANA. By the way, what is SAP BW? Any idea? Anybody has worked with the SAP BW before? Can somebody throw me a light on that? What do you know about it? Because it's better that you should have a little comparison between BW versus HANA.
I haven't worked on that BW, so I have no idea about it.
Okay.
That's how it looks like. I don't even know that.
That's okay. I'll just put major difference right now for you. But let me ask Asman Kamran also. Do you know, or have you ever worked with the BW?
Sir, BW is basically I use as for the reporting tool, because as per my knowledge, BW server where the data is basically settled in form of cubes, and then the queries are generated. So my role was basically to select the queries, and the IT people basically run the data, and then the data is abstract from in form of reports. Because it is utilized for the reporting purpose, I use BI and BW, but not I have much knowledge about its structure.
Okay, that's nice. And Asma, you worked with the BW, or you heard a little bit about it?
No, I'm not familiar with BW.
Okay, so that's okay, because it's a kind of data warehouse thing, because we're talking about data warehouse. So it's better that we know a little bit about it. It is actually an enterprise data warehousing solution from SAP. So what it offers for us is, fundamentally, it has three things. The first thing is it has ETL. The second thing is it has data modeling. The third thing is it has data reporting. It has all of this packaged, and then we could very well use this to actually construct enterprise data warehousing solution for our company. Usually, in the market, we have separate tools, ETL, such as Informatica and Cognos and all other things, and data modeling, tools also, such as Edwin and some other computer-associated tools. And we also have the reporting tools, such as business objects and other reporting tools also in the IT industry. But this one has all of three things inside, bundled inside this product called SAP BW. So that's why it has become more famous. More number of companies have implemented this. This is very sophisticated, much advanced, technology from SAP to construct a data warehousing solution. For constructing a data warehousing solution, you require actually three type of technologies. The one is ETL, and then the two is data modeling, and three is data reporting. It has all of this. And right now in HANA, what we have to discuss is we also have to know where we stand in terms of BW and HANA. Let me just give you a little background on that. See, even though it is very, advanced and sophisticated technology, SAP BW, it always, has to depend on the underlying database that we have, So this database is going to be third-party database. So it is limited in its, speed and other delivery aspects, just because of the fact that the RDBMS, underlying RDBMS, is a traditional RDBMS. See, this is an application layer. BW, what is BW? It is an actually application layer. So it does not hold any data. The data is held here. The data is held here. So the fact that the data is an RDBMS, it always, the whole solution is limited, because the RDBMS is, if it is a RDBMS is a traditional RDBMS, obviously we know the limitations of the traditional RDBMS. We had already discussed. Now imagine if we have HANA here. The things are different. And again, another question is here. We are talking about SAP BW is a data warehousing solution. And then why do we need to have SAP BW again when we have SAP HANA? Because SAP HANA itself can be a data warehousing solution itself. Any answer for that? No? I hope you got what I'm trying to say here.
No, can you please say that again?
I was saying we have SAP BW. is a data warehousing solution. I think you got the point how the SAP BW works. And now, just because of the fact that we have traditional RDBMS as an underlying database for the SAP BW, so the power of the SAP BW is limited by the traditional RDBMS situation, because traditional RDBMS usually is actually row-oriented, sequential, and not massively parallel processing, and does not do so many other technological aspects that HANA has, and it is limited by its power, by its speed. So the whole enterprising solutions could be, not helpful in terms of dealing with huge amount of data versus the required speed that we are targeting. So in such case, if I bring SAP HANA as an underlying database, obviously the things will be much better here, because HANA performance comes into the picture to help the BW, and obviously this is going to be right now in industry we have several implementation where HANA is a database for SAP BW systems. But now my question is, HANA itself can do data modeling and can play similar to the BW role as we are trying to learn. So why do we actually go for SAP BW even though when we have SAP HANA? Here, the existing implementations, see, there are several customers right now in the industry. SAP has so many customers right now who have implemented SAP BW, okay, with underlying databases, SQL Server or Oracle and other databases. SAP cannot ask probably the customers to actually replace the whole thing into SAP HANA because they have spent so much of time, resources, the whole infrastructure landscape, they made it ready and things are working out. So only thing that they do is they try to replace just the database, because I think it's going to be expensive to actually replace the whole solution and then completely scrap this out, the existing solution, and then go for new implementation. It'll be more costly, affair, more time-taking affair. So the only best way is just adopt SAP HANA as an underlying database. So they try to migrate the data. So we will have data migration projects, and at the same time we will also have to match with the problems between SAP BW and SAP HANA when we actually bring SAP HANA as an underlying database. So right now some of the projects are going when you see the recruiters, you can find that people would want to migrate from their traditional databases into SAP HANA, where this SAP HANA will be as a fundamental database for the SAP BW system. But on the other hand, if somebody would want to construct or make this enterprise data warehousing solution for their company for the first time, so they can just go for SAP HANA native application. They do not have to go for SAP BW. So you have both the situations right now in the industry. Is that okay? And I hope it makes sense what I spoke to you. I was actually trying to, log on to the login ID that I was. Anybody got the, remote login credentials? You try to log on to the system.
No, I did not get the server access. I sent you the meeting link, but I don't have the server access yet.
Okay, but it doesn't work right now. I sent a email saying that it has to work and things like that. But at the moment, it doesn't work for the moment. Probably I'll try to open my other source studio and show it to you. But at the moment, we just try to understand this, multidimensional modeling, how it works. So data warehousing has all these aspects of gathering the data and then cleansing, integrating, and which means the first two steps are ETL, and then you have the reporting, and then before reporting, you have to mine the data probably, and you may have to come up with different modeling artifacts based on your data. By the way, what is data mining? Just to put it in one word or one sentence, because we might have to do a little bit data mining also in our SAP HANA. You guys earlier would have obviously worked with this data mining or not? See, we have so many buzzwords in the industry. Yeah, you have data federation, data warehouse, database, data mining, and all these things are, you know, similar things a little bit. There is a aspect of it. Yeah, we have to get to that. Yeah, Kamran.
Sir, I am here.
See, basically, okay. I just put it in a simple word. We just try to look into the data to find the patterns inside the data, such a way that we find, you know, we try to excavate unknown. We try to discover things by looking at the patterns inside. So we have to conduct a certain type of analysis in the database, obviously, and to actually in order to discover these patterns. That the whole process is said to be data mining. So we'll be also doing that, and
can you please say that? Explain that again. What is data mining?
Okay, that's nice. What we try to do is, let's say we have a database.
Mm-hmm.
So in the database, we have so much of information. We have n number of tables, and then which are connected. And then let's assume that this database has the transactional data for the moment. Let's say it's a transactional system. So we are ending up with this database on a daily basis, hourly basis. Transactions are being dumped into this database. So end of the day, you know, it deals with some business. It deals with the business functions. So you might want to discover something unknown according to you. So the business at the moment, you know, we see lots of data, but we want to find out how they relate to each other. We want to, you know, make something out of it by saying that, you know, yes, the trend is going this way, the pattern is going this way, so the data match is coming up this way. So how do I discover those unknown things by actually looking into the data structures inside and the actual data itself inside the structures? So that process is the process of finding patterns inside the data is nothing but data mining. So you actually, it is a very vast subject, and you have so many other tools in the industry for that, but we do up to some extent in SAP HANA. We still do that. In any data warehousing solution, you will have a data mining up to some extent, obviously. But if you go to data mining, pure data mining, you may not be having data warehousing aspects. But inside the data warehousing aspects, the way how we have the database aspects, because they cannot be a data warehouse without database, right? The same way, they cannot be data warehouse without data mining aspects, because we try to dig into that. We try to dig into the data to find something, to discover something, to conclude something on top of the data that we have, daily based data, transactional data that we would be having in our system. That's okay?
Yes, thank you.
Yeah. And this process will be very interesting. Remember, you're going to be dealing with the huge amounts of data. When you come to HANA, so the data is going to be like I discussed in the first few classes. HANA is, you know, is there for you to handle huge amounts of data. It will compress and it handle, but end of the day, you'll be looking at the huge amounts of data. So if you want to, you know, make any query on top of the HANA, obviously the fundamental query, if you want to write SQL query, it is going to be probably complex because you're dealing with huge amounts of data. Sometimes it takes so much time and it requires so much understanding to actually make an SQL query on top of the data. It's still possible, but that's why we do not do that. We actually move on to the reporting technologies, which has this facility. We try to, you know, solve this querying process in a layered manner. We try to set one reporting layer where we try to use those technologies to actually query on top of this database. That's why in this class, in this SAP HANA, we try to learn all the data migration techniques as well as data reporting techniques. Also, some of the data reporting techniques are outside of HANA box, So we may have to go to the SAP Business Objects portfolio products, such as Business Intelligence, Web Intelligence. Oh, we have to learn how to do that also. So we have all these things which we'll be doing in HANA. So let me get to the multidimensional modeling straightforward. Before that, I hope I do not want to discuss on OLTP versus OLE. Please interrupt me if I have to discuss a little bit on that. I assume, these are the fundamental things that you already know it. But if you still require, a little bit points on this, you can just buzz me, okay? So there is something called OLTP and something called OLE because these two systems are fundamentally different. The OLTP system our systems are your SAP functional modules such as SD, MM, and all your functional modules you have, right? Those systems are said to be OLTP systems, but SAP BW system is an OLAP system. The system where you conduct analysis, the system where you have multidimensional objects, the system where it hosts the data warehouse is said to be OLAP. On the other hand, OLTP is a database, transactional based, operational based system. So you have several other differences anyway, you can just get to that. So I discussed this data models yesterday. So I'm just moving on right now to the next slide, but please buzz me if you have any, emphasize on. If you want me to talk about this again today, about the data models, you can just buzz me again anyway, right now. So I'll just move on to the multidimensional modeling. The basic fundamental object in the multidimensional model is, if I look at the model, I first have to conclude the structure. See, let me again ask you the very fundamental question because this is very important. The physical table versus the view. I have already discussed a lot on this, but you have to put something to me on this because only then I could jump into the multidimensional right now. I don't know, Cameron, I want a little bit difference between the physical tables versus the information view.
Sir, honestly, I do not have it. I never gone through from structure of product.
Okay.
Actually, you told, I forgot, you told that to us yesterday.
That's okay. I'm going to repeat. Yeah, Asma, I'm going to repeat this because it's very important that you should know this before we jump into the multidimensional modeling. That's why. I just want to emphasize here. You have any idea, Asma, on this?
The information view is just a read-only, right? And physical is where you're updating transactions.
Okay. Read only. And what is the second point you said? Updated transactions. Is the physical table.
In the physical table, right?
Okay. So this is one point. That's okay. I got it. But to illustrate the fundamental differences, we need some more points. Basically, we have a we have a physical table. Let's say 3 columns. When we do the data modeling, so what is data modeling is all about? Data modeling is about actually, creating information views. Then immediately, what is an information view? That's a question, right? Assume that, we want to deal with this table by querying, isn't it? So what happens is, if I have one table or 2 tables, honestly, or few tables, 4 or 5 tables, we do not need information views mostly, because we can directly get onto the tables and query them. But 2 things I want. I want to reuse my work, reuse my work. I want easy management of my work. Easy maintenance, I'm sorry. So my work means my work towards querying the system. So what happens is if I query the system, the table, I get the answer. I just write SQL query or something. So going forward, what happens is if you have more number of tables, you may not be dealing with, you do not want to deal with the tables directly to query on top of it, because you might want to reuse that queries going forward. Because see, any business, if you fundamentally if you look at the business requirement, it will have set of queries. And when you look at the way how the query works, fundamentally there are queries that you can reuse them in the bigger queries. The second is when you want to maintain them, for example, those queries, so it is easy for you if you have actually alternative way rather than approaching on the tables directly with your query. The best way is I try to take I try to say this one is right now is a full container. I try to define like this always, where it has complete data in it and then structure also. So now what I do is I try to say something like empty container, which is a view. And then what I do is here, I try to create a view here based on this table. I try to create a view based on this table. But this view is, this empty container does not hold the data as the name it says, it's just the structure. So just like empty container does not have the stuff is in the full container. But at the same time, the structure also does not necessarily the same structure as the full container. It is a subset here, remember, it is a subset. The structure is here. Subset of the full container structure. Which means I might take only 2 columns from this or 1 column. If I say 2 columns, I have probably more than 3-4 options here, because first 2, second 2, or third 2, and all these options we have. So now the fact is, why do I do that is I wanted to deal with the structures when I am querying rather than dealing with the physical tables itself directly, because I can reuse them easily. Whenever I want, I can just plug in the structure. I can easily maintain them, because if I just change the structure, so wherever I use the structure is also going to be changed. So that way, my information view is a kind of structure that I create just to attend to the queries. This is not an easy job if you have n number of tables. You know, it is going to be a huge task if you have, let's say, 15, 20, 30 tables, because if based on the business requirement, you have to come up with your own information models, information views, design such a way that it fits exactly to your business requirement, you know, easily to attend to that business requirement to report out of it. So the whole process of creating this information views is nothing but data modeling. So you got it? Is this fine? So we're going to create right now the simple information views, and then complex information views, and then much complex information views also. And then there's going to be a one complete information view end of the day, which will give you a solution for your business requirement. To arrive to that, you have to construct building block, like a building. You know, you start with the bricks. With the bricks, you make a room, and with the rooms, you make a floor. With the floors, you make a whole building. The same way, the whole information modeling system things also works. We try to design the smallest artifacts. We use them. We cook them, and we make the bigger artifact, so on and so forth, to arrive to the huge complex information modeling artifact, which is a solution to our business requirement, the data modeling. Hope you got this, yeah? So that I can just move on. Are you done?
Yes.
Okay. So if you can excuse me, I'll just take 10 minutes break, because I just have to put my son in the school, which is next to my building. So just give me 10 minutes break. I'm back. Is that okay?
Okay.
Exactly
No
10 minutes.
Yes.
Exactly 10 minutes. I'm
Yes.
back to this break. Thank you. Thank you very much.
Thank you.
Hi.
Hello.
Hi, I'm
So can we talk? Yeah, I'm sorry I'm back. I had to take a break.
That's okay. We are here.
Okay,
Yeah,
sir.
so, yes, and can I just move on to this, multidimensional artifacts that we are trying to, learn today?
Yeah, go ahead.
Basically, yeah, thank you. Basically, we will actually be doing, we're inside the SAP HANA data modeling right now. We are actually trying to do two-dimensional modeling artifacts, and we will reuse them. In fact, we will use them inside our multidimensional modeling, and then we create, simple multidimensional modeling artifacts, and we move on to complex multidimensional modeling artifacts. The simple one right now I have here for you is a star schema. This is how the simple one works. Let us just understand this. And here, to list out simultaneously inside the HANA, how the names of this, the HANA terminology. We say attribute view, and we say analytical view, we say calculation view. So it's the same thing of HANA terminology. This side, the left side, what I put it here is actually in general, multidimensional modeling artifacts. We call it two-dimensional artifact and simple multidimensional artifact and complex. The same thing here, the two-dimensional artifact is set to be an attribute view inside the SAP HANA. We're going to see more of this. We're going to be creating more of this going forward. And then we'll be also using the analytical view, which is actually the simplest multidimensional artifact. So with analytical view, we are entering into the multidimensional modeling. And then we are moving on to complex multidimensional modeling with the calculation. So this is how it is. So let us learn what is the simplest multidimensional modeling right now. So the simplest could be the star schema. And the star schema works like this. You have a central table surrounded by the dimensional tables. The central table is called a fact table here. The say is here, a fact table. And then surrounded by the master data tables, which are dimensions we call. We also have something called, dimensions, facts, or we say measures. These words will come into the picture quite often when we use this. We will see what it is. Right now, we will see what it is going, just give me a moment to come to this point. Let us just see what is a star schema. So the star schema, we have this dimension surrounded by the dimensions for this is a transaction table, first of all. The sale table is a transaction table. And then the customer, store, and product is a master data table. You agree with me? That means the transaction table is going to be central, which will act as a fact table, which is surrounded by the master data tables. So how it is surrounded by it? Obviously, we have the join effect here. With the join, you have this primary key and foreign key effect. But all these, what I'm talking is product, sale, customer, and store. All these not necessarily be the tables. They could be also views, because once you enter into the view modeling, information views, so you don't mind using view or physical table in the process of making another view. So in the process of making bigger view, or so this does not have to be a table. This could be a view. Obviously, mostly it is views. The difference I told you, the views and tables. We always talk about views in the modeling environment because we're not going to deal with the data until we go into the consumption, which is the reporting. Before that, we are making our ground ready for the consumption based on the business requirement. So what we try to do is we try to target on devising information views in a continuous manner. So the simplest modeling artifact right now I have here is a star scheme. It looks like this. Let us go a little deep into this. It has, like I said, it has facts, it has dimensions, it has measures. See, one question I want to ask you is, in the database systems for the table or views, in the regular database RDBMS, so we only have the attributes. We do not have measures, right? All these are attributes. You agree with me? Let's say right now in this table I have 4 attributes. So each attribute represents its column. And then let's say I have 4 attributes here. But in a multi-dimensional modeling, this, if you look at this particular table as a view, in terms of structure, you could have 2 possibilities. Not only attribute, you can also have a measure. So that means in any multi-dimensional view, if it is a 2-dimensional view, this is the thumb rule you have to remember. When I say 2-dimensional view, when I say multi-dimensional view, here we only have attributes. But whereas in here, we have attributes and measures also. That means we have to understand what is a measure and what it does for us, because this is something that it is being introduced in multidimensional modeling. We do not have that separation. Or even whatever it could be a measure or anything, we just call it as an attribute inside the 2-dimensional view. We don't separate them, we don't segregate them, but here in multidimensional you have that. So let us see that, because the fact that we just entered into that simple multidimensional artifact right now, we see that. We also start putting these measures. And then here, all these are the dimension tables. The central fact table is the one that we call it as a fact table. It is a transaction table. You can also call it. Mostly, it doesn't have to be 100% transaction, but technically, all the fact tables are transaction tables. And then these dimension tables are 2-dimensional tables actually, or the views of the 2-dimensional tables, which are master data tables here. So then what are the measures? Measures are something that you see here, quantity and amount inside the fact table. So that is something that a measure, which will give, it's a business parameter, which will help us to understand that particular business aspect. It is always a quantity. It is always something that measurable. Attribute is something that a characteristic. The measure is something that which can be measurable. But I have a clear-cut differences on these two going forward. It's just at the moment you just get to that only. And the star schema works like this. It works in a way where the join is directly connected to the every master data tables, obviously, which means there is a key here, foreign key, primary key effect. For example, for the product table, you always have product ID this side as well. At the same time, you are store ID. At the same time, you also have customer ID, so that all these IDs, or rather keys, will help your fact table to be tying up with the other dimension tables, so that we could traverse this table and then get into this information in a way where you have the measures here. So what happens now is, for example, I can find out this quantity can be in terms of store, in terms of product, in terms of customer. That's why we call them the dimensions. So when I say quantity, then the immediate question is what quantity? Is it a customer related quantity? Is it a store related quantity? Is it a product related quantity? So all these we can get to this using this. That's all the beauty of the star schema. So the amount also the same thing. When I say amount, it is what amount it is. It is a store related amount, or product related amount, or the customer related. So various dimensions we have for every measure that we have here. So the dimensions are not necessarily, 3 or 2, it could be 5, 6, 7, but the central fact table is always 1 in this, simple multidimensional artifact. And okay, you got this up to this? Any questions?
No, I don't have any questions till now.
Okay, so we will be doing this in SAP HANA as analytical view. The same thing, whatever I spoke to you now. I will be demonstrating how to create this, and we will be creating several number of analytical views so that you can understand actually. And then the first one is the attribute view, which is a plain two-dimensional view, So we moved on to this multi-dimensional. Let us see. And we have something called hierarchies. In the same, I'm still in the simple multi-dimensional structure only. I'm still not moving into the complex, but inside this simple multi-dimensional structure, I could have hierarchies. Anybody worked with the hierarchies before? Let's say parent-child hierarchy, level hierarchy, or whatnot, could be some other hierarchy. So hierarchies normally help us to make our aggregation more easier to traverse between, from one level of hierarchy to the other level of hierarchy. For example, here, the store we have here, the store we have right here in this, the store is this. Further, if I want to break down the store into a couple of varieties here, I could say whether the store is, in a village or in a downtown or in a suburb, or I can also classify that. Then I could say that store type, and immediately I can have another point saying that whether the store is, comes under which city. For example, it comes under North City or South City or something, and then I could say it comes under which state or which region. This goes like this. This is why this is because sometimes my dimension requires more details. Right now I'm talking about store as a dimension. That's why we call this as a dimension hierarchies. So sometimes in your analysis, you might have to break down your simple dimension into little more, number of dimensions to get a depth of it, to actually get more details of it. Your business requirement says, and then if you have information in your master data tables corresponding to that requirement, obviously the situation will be like this. So the store does not just end with the store, table. It will have a couple of other tables like this that it shows. So what happens right now is, if you move to this direction, so our fact table, our star schema becomes like this. So earlier, let's say we have a star schema like this. This one is 1, and we have 3 tables surrounded by this. Assume that we have for the moment star schema like this. But by introducing this, what happens is here, this is a simple star schema. But here, I need to, further extend the dimensions, dimensional hierarchies in a particular dimension called store. So what happens is my star schema becomes like this. I have one more like this, and I have, and then you have the same cities further extending to the other one, so you still have further extension. This is, so look at this now. It is a little bit complex than the simple multidimensional schema that we see. The first one is star schema, but this is called snowflake schema in general, which is this snowflake. This is not the simple anymore. This was not really simple anymore, which means we could have more possibilities like this also. There could be another table coming up here. which illustrates further extension to this dimension. And this could have, one more table, further extension, and this could have one more also. Here also could have one more, just one. See, this is a fact table. And all these are the dimension tables. This one is a dimension. This one is a dimension. All these are the dimensions. So in such case, this is set to be a snowflake schema, but we don't. In SAP HANA terminology, we only take it as a calculation view. We only have 3 views like I discussed. So in this, the further complexity is going to be like this, which means we will be having, similar to this another fact table coming up next to this. So it's like this. You will have this fact table surrounded by the dimensions, but this particular dimension again is connected with the another fact table. Obviously, you have another star schema here. So it is like bringing 2 star schemas together, or 3 star schemas together, 4 star schemas together. What happens is that is something which is more complex. So actually, your business requirement ends here. It will not end in a simple manner, but you start from the simple manner to when you devise your solution. You try to construct from the simple models, but to attend to your business requirement, the whole business requirement, always the solution is going to be, in the with more number of fact tables bringing together, where more number of star schemas are together connecting each other, or you have a particular solution for one fact table, another particular solution for another table. You want the result. You might union them, or you might bring the intersection of them, and then take the result and then put it in another fact table where that fact table using this result, and then further moving on to the other complex structure. So it is like this. Basically, what I'm trying to say is that the solution, the end solution for any business requirement is usually a little bit complex, but the modeling only the complex. You are making the views complex in order to make the solution simpler, because from the reporting point of view, imagine the moment you have this complex structure available based on the requirement, it is business requirement optimized. So the reporting consultant, it is easy for the reporting consultant just to knock on the information used to ask for the data that he is looking for. See, obviously the reporting, what they do is they would want to narrow down into their own aspect of the data that they are looking. It's like filtering only. You see, you have like 100 terabytes of data, but at the end you might be looking like top 5 people, or who are the best customers doing in the year 2019 versus year 2011, and the same in that area, or in the difference when you look at the country versus countries. So you're bringing 5 to 10 countries, different business parameters, and try to compare. So you do like mostly your analysis would be going to be forecast analysis, or trend analysis, or sentiment analysis, or predictive analysis. All these things requires these structures. Okay, so let me just go on how this works. Okay, then what is cube? So far we are fine. Then now the question is, what is cube? We spoke about star schemas, we spoke about snowflake schemas, constellation schemas, the complex structures, the same way in SAP HANA terminology, which is attribute view, analytical view, and calculation view. But something called cube. Cube is nothing but, it's the same thing. But when you see this, the fact table is nothing but the cube here. How do we call this as a cube? Because if you go back here, you see the cell here collects all the facts from the surrounding dimensions. It has a depth actually. But if you look at the sale table, it looks like a two-dimensional structure. It is just a table end of the day, isn't it? The table could be like this. I'm not putting here the customer ID probably. I only took it to product ID and store ID. For example, if you take a simplest cube, a fact table with 2 dimensions. This is a 2-dimensional fact table, not 3 like I showed the example. So assume that it has like this information, but it means like this, right? When you actually look at this, like I said, the amount here is a measure, has two perspectives, a store perspective and product perspective. That's why amount is two-dimensional here. So multi-dimensional here is just two-dimensional in this case. If you have three, for example, here, this is a three-dimensional. If you have four, it will be a four-dimensional. That's what we call it multi-dimensional. The minimum is two, it starts from two. And then if you have five, it goes number of multi-dimensional, and number of dimensions goes, it could be more than 5, 6, 7 also it could be. But if you look at the two-dimensional, it looks like this. Do you agree with me? It is like it has a depth of 2 dimensions. It is nothing but the beauty here is you can still put multi-dimensional cube into your table. It is just a 2-dimensional table again. Do not get confused with that. The depth is multi-dimensional when you actually look at it. But from outside, if you look at the, it looks like just a table. It is a relational table. So that's why you call OLAP, when you say this is an OLAP object, right? You can say this one is also OLAP object because it is multi-dimensional, right? OLAP is for the analysis. Any object that helps you to conduct analysis, which is an OLAP object. The 2-dimensional objects are the OLTP objects. So right now, if you look at this, the depth is 2. Then how can you go inside? If your depth is 3, you can actually illustrate. The left side one is the actual one. Right side one is an imagination. You know, the same thing here. The left side one is an actual one. It looks like a table. But to see the depth actually, to see and to differentiate with the 2-dimensional tables that we had in the RDBMS, we had to do this imagination, which is on the right side. You see the right side imagination right now, which means it has like this. Imagine if we have 4 dimensions. I don't think we'll be able to put it on the paper, but you can imagine how these cubes are helping us. Cubes are very powerful. How can we construct the cube? We require star schemas. Only then we can collect a fact table. Once we develop a star schema, once we end up having a star schema, the fact table becomes your cube. The cube will have a depth of dimensions. The dimensions could be a depth of 2, 3, 4, so on and so forth. So right now I have 3 dimensions depth, which I can imagine like this. It could be day 1 information in one layer, day 2 information in the other layer. Each layer contains again 2 dimensions, which is product and store. So if I have 4 dimensions here, you can imagine how to put it. Maybe we're not able to easily put it on the paper like this, but you can still imagine. This is how the whole analysis works. It is more easy for us to conduct analysis if you move on to the multidimensional modeling. Otherwise, just imagine the same type of results for the same things if you want to get to it without having the multidimensional. So how much complex query you have to type? You still can do that, with the same product table, store table, and the sales table, and all these tables. If you have the 2-dimensional tables, you can still get to this by querying it, by making a complex query, but it is going to be complex always. So since you are in the analysis, you make the structures easy. Maybe the structures are complex, but querying on top of it is very easy, very simple, because you have most of the values ready. For example, here, I can get to this value, which is a day 2 of C1 and P1, which is a product 1 and C1. This one is a 44, for example, the amount is. So I can get to this very easily if I have cubes. So the idea now is we'll be developing these cubes in our SAP HANA Studio. And is this clear? Okay, thank you. I don't know if it's clear, fine. And I want to move on to the aggregates, because here we require this aggregation also in our analysis. The same example, if I want to tell you here, the aggregation comes of this amount. If you, the sum could be an aggregation, as we discussed. The average could be an aggregation, the minimum, maximum. having, not having, or when anything you're dealing with all these things to conclude is nothing but an aggregation here. You have, when you're dealing with all these objects here. Here, I can say aggregation is like this, but another thing is, at the same time, you can also group the aggregations again. Based on the dimension you can group. For example, one dimension could be date here. The other dimension is amount. One dimension could be a product. The other dimension is a store here right now in this example. So here, in the aggregation also, if you say group by date, you have, for the one you get this aggregation. For the two, you get the aggregation. For that, you use this simple SQL. But SAP HANA, it does it automatically. When you move it to the cube, the only thing that you have to make is the cube. Inside the cube, you have to work on making your measures, which are this amount is a measure here. So once you have measures, HANA automatically helps you to get aggregates on the fly. When I say on the fly, what does it mean? Traditional data warehousing systems such as PW, you require all your aggregates to be created while you develop itself, while in the implementation itself, so that when you consume, those aggregates are ready for you to pick it up from the consumption side, from the reporting side. But here in SAP HANA, we don't do that, because SAP HANA is so powerful. You just have to segregate, organize the data as per the rules into the multidimensional objects. So the aggregation will happen on the fly, which means as and when you consume, which means as and when the reporting technology requests for data, the aggregation happens on the fly. That is what is the beauty of SAP HANA here. So how they could make it? So they could make it like this, the way how we simplify, the way how we segregate these models, right from the simple modeling artifacts until the complex modeling artifacts, the way how the whole modeling structure evolves. SAP takes care of it. SAP HANA takes care of it step by step, while in the implementation itself gives an opportunity to traverse through various aggregation. So various aggregates here. And here, another example could be, you could actually group by not just one element. You could also group by more than one. So aggregate here is coming for particular product on a particular date again. So which means on the particular date there could be more number of products, so on and so forth. So all this can also be happening. And let me just see if I can log into this. I think it's not working still. Normally we use this IP like this, and we copy onto this place. You do the same way. First MSDSC you do. You used MSDSC before, right? I just use MSDSC, and then we try to do this IP and username as well. Oh, it still doesn't work. It had a problem. So I think I asked him to fix it up. We probably will do this in the next class. I will be showing in the next class about the HANA Studio. So let's just go into the same topic so that we don't waste our time. So right now, this will be going on. If you have more number of dimensions, obviously you can group by the dimensions. Here, date is a dimension, product ID is a dimension. So here, the difference between, one more time, so dimension is nothing but an attribute in our SAP HANA. Remember that, okay? In SAP HANA terminology, we come to attribute views. That is the first two-dimensional object. We bring as a dimension to the star schema, because the central table is a fact table, surrender tables are called dimensions. So all these dimensions in the star schema are, all these are attribute views here. This one is an attribute view, this one is an attribute view, this one is an attribute view in SAP HANA. After having this transactional table here, the whole thing is set to be analytical view. So the whole thing is set to be analytical view. See, the concept is same. We have a terminology. When you go to BW, you have a BW terminology. When you go to SAP HANA, you have SAP HANA terminology. So that is something that you got to adapt slowly. So after this, so I just wanted to conclude. Aggregates are very important that we'll be playing in our modeling. We'll be doing all this. So the same thing, like I explained, it could be any of this aggregation is. So we will see that. And okay, let me just see this. When you have the, right now we have seen how to build, let's say, multi-dimensional objects. How to build multi-dimensional objects. And then the next thing is how we can actually, since multidimensional objects are complex in nature, we'll be having a complex multidimensional object. Your requirement will end with a complex structure. And how you can traverse through. So how I can traverse through is basically I require some operations to actually get inside it, because it's not simple. It's not just a table or few tables connected. It is more of, if you look at the complex one, it will have more number of fact tables, more number of dimension tables, and then the connections, so many, the connections are nothing but joins here. And then how do I traverse to get the data that I'm looking for? So the data that I'm looking for is the request coming from the reporting technologies, which is actually the querying actually. So how do I get to that? So there should be some operations, right? Those operations are called here roll up, drill down, slice and dice, and pivot in general. These operations, the same operations we'll be using in our SAP HANA also. But we don't call them up with these names, but indirectly you see the process is the same process that we see when we want to get inside the multidimensional modeling to get the data what we want. Because everything is there, but what we want. So in the complex structure, there are so many things, but based on what you want, you get to there. You get to the fact table, or you move on to the dimension, or further from there you move on to the hierarchy, or where, which one. So you are actually, you would need to narrow down the data, the whole data, based on the business requirement that you have to actually bring the results to the business requirement that you are looking. So these operations, we have this. So the roll-up could be, by the way, You know these operations? Better I discuss this because it's more important if you don't know.
I'm not familiar with any of these operations.
Not sure, right? Okay. Okay, but so far you're getting what I'm trying to say, right? In the multidimensional objects, multidimensional modeling. So far
Yeah,
it's okay,
right? Yes.
Okay. So now assume that, I was trying to assume that we have a multidimensional object like this because it could be even more complex than this. So let us assume first operation that I have for you here is roll up. Let us see how this works. So we have these operations. So the first one I'm taking it as a roll up. Roll up is something that, it works like this. You have to, when you're rolling up, you are actually cutting down the dimensions, simple. Only you can roll up. How this can happen? For example, I have, the time is I have quarters, and the cities are, I have all these American cities, Chicago and New York at the same time. I have Canadian cities and I have other cities because my data is dealing with more than one country right now. So the roll-up means it's just winding up the dimension reduction. You're actually aggregating the dimensions into a much bigger dimension. Here, the rolling up could be a country, which means all the data that you have in the city levels needs to be aggregated into the country level. All. So what happens earlier when I have Q1 Chicago, right now I only have Q1 USA because all the cities Q1s are aggregated into the country. So this process is nothing but rollout. We do that in our multidimensional objects when we have it, when we have to conduct, when we have to make operations to attend to our business requirement. We do the combination of all these operations. See, whatever you see here, operations. So we do the combination of these operations. This one, sum of this operation, 2 times of this, 1 time of this, and then 3 times of this, then you get your results. Like that, you do the combination of these things actually to get to your point. So right now, the first operation that I have is a roll up. Rolling up means you're actually reducing your aggregation, dimensions. You're actually cutting down your dimensions. Or rather, you're actually aggregating the dimensions going into the other depth, the much bigger perspective, from city perspective to the country perspective here, or from the country perspective to the continental perspective. All these are nothing but roll up. So in this roll up, what happens is you cut down your dimension. So the number of dimensions here are less. After the roll up, the number of dimensions are less. For example, you have 40 cities in 5 countries. Here you have 40. Before you rolling of 40 dimensions becomes 5 dimensions. Here 5 countries, 40 cities becomes 5 countries. But all the data needs to be aggregated. That is something that HANA is going to take care. If you follow the rules of modeling while you implement the modeling, while you conduct the modeling artifacts, if we follow the rules, if we give all this information, if we mention the hierarchy, everything in a proper manner, we can use HANA to traverse back and forth. We can get to this using the roll-up, and we will see what operation we require from here to here again. We will see that. But for now, from here we can get to this using the roll-up. So that's what is roll-up. And then drill down is something that the opposite. So when you want to come back when you want to do the opposite of the previous example that I gave you. So drill down is something that you would introduce more dimensions. For example, you have right now only 5 dimensions, but you end up having 40 dimensions after the drill down because you want more details. You want to get into the depth. So from the, for example, in this time, not necessarily countries drilling down countries into cities, sometimes the quarters into the months also, anything. So here, this example says quarters into the months. So what happens here is, right now, I only have quarter level, aggregates. So the quarter level aggregates are split into the month level aggregates. For example, this 605 is split into, let's say, this 400 is split into 100, and 50, 100, and 150. So for these 3 months in 1 quarter. So that way you would end up introducing, for example, these 4 dimensions becomes 12 in this, or this 40 city becomes 5 countries here. It could be anything. So the drilling down means you require more depth, more details. Remember that way. If you want more details, you have to introduce more number of dimensions. That means here the number of dimensions are getting added here. More number of dimensions are getting added. So this is the opposite of the previous one. We'll also do this. We could be doing sometimes, roll up and then do something, get out there, and again drill down also in order to get more depth of the requirement. You have the slice operation also again. What this slice operation does in your modeling here is it just takes a slice of it. For example, you have, assuming that this particular modeling artifact or the cube right now has 4 layers of, let's say, 4 quarters. So like 4 slices, rather, I would say. So one slice could be taken out by just cutting it horizontally in this example, or could be the other way also. The slice is a portion of it based on one particular dimension perspective. So here the dimension is the time. Otherwise, if I have countries, 5 countries, so one country information could be one slice of the whole. Could be like that also. And you have something called dice. Dice is the same thing, but it's a little bit. It's a subcube of the whole cube. You actually basically take a little bigger portion than the slice. The slice is the tiniest portion here. But here you combine like a couple of slices, it becomes dice or the subset of the cube. Because why do we are talking all these things is your requirement might ask you to dice it, and again same time to slice it, and then drill down, get something, and then at the end maybe we have to drill up also to actually come up with the results when we actually want to send the results to the output result set. So all these operations will be done accordingly based on the requirement. So the toughest part is making these objects. The doing is more easy, but the making these objects, arriving to the complex structure in a project is a little bit of work. I mean, it is a little bit of work to do that. But to traverse through is not a big deal. So to conclude that the complex structure is something that you will have to work over a period of time, because it will have more number of multidimensional objects connected to each other, and the structure could be a little complex also. We will see. In our example, I have a project called Cost and Profitability Analysis, COPA. That deals also with some amount of complexity. I have one complex structure in there for you to show you in the HANA Studio, so that it will be hands-on experience for you to deal with the complex structures. And you have something called pivot. Pivot is just you have this. You just change the directions of the axis. For example, you make them vertical becomes horizontal, and horizontal becomes vertical. Sometimes you want that. You might need to rotate it, because in your traverse, sometimes it's more easy. You just rotate it and traverse through with these operations rather than just traversing through. So that's why you require also pivot. Okay, so this is what it is. So any questions from this? So we spoke about the in general multidimensional modeling, how it works, in general multidimensional structures. So I want to bring this into SAP HANA, the same thing, SAP HANA point of view, the terminology I'm going to add right now. The same thing will be there, but the terminology is going to be SAP HANA right now for you to get into this modeling. So is that okay until now? It is better if I can show you the tool right now, but for some reasons it's not working. Let me just open with my other access I have. Just a moment. Please ask me if you have any questions, so that I'll try to open the tool and first to show you. I have here some, 1 minute, let me just get to this. Okay, let me just try this. You there, Aruna? Is it okay? The multidimensional modeling is fine with you? Kamran? Asma, please.
Yeah, I have a question. So it seems like there needs to be a really heavy on the SQL, even in the data modeling. So you need to be super proficient in being able to write these queries?
No, actually it's not like that. Yeah, that's a good question. Let me tell you.
Sir, honestly, this is new thing for me. So I have to hear your lecture again and read the material, then I will get more flexible.
Because this is a little complex. Please try to understand. Yeah, he is right. Kamran is right. You have to go through a little bit things and then see SAP HANA modeling. We can do mostly in two ways. One is GUI based modeling. The other one is SQL script based modeling. The third one is a combination of both. Mostly in the industry right now, we use GUI based because it's more easy. So do not worry, you don't have to know so much of SQL, but you have to know the fundamental concepts. What I mean is you have to know how in general, the data modeling works and step by step how to create it. This GUI based modeling only I'm going to emphasize more because it is more easy to learn if you follow certain rules. So you don't have to worry on so much on SQL, so much complex SQL. You can still master the complex modeling artifacts you can create using the GUI also. But we have to follow it step by step. We have to build it. The structure becomes complex step by step. So you start building the small multi-dimensional objects, then make it complex, and then bring them together to bring even more complexity.
Sir,
yeah,
can you fix the server? So once these theoretical material will be applied, so it will be more productive.
No, I mean it is more easy if you know this theory on the server. It is the other way, sir. If you ask me. So if I go here and start developing, you'll be actually looking at more disturbed or more the concept you have to get it first. Because I can just jump on and make a complex modeling artifact here in half an hour time, but the problem is you have to know it, how I'm bringing that complexity, I start, if you are not from the modeling environment, if you are not from the data warehousing side earlier, because I assume that you are not from the data warehousing side, that's why I went on to this multidimensional structures.
Yes, sir, you are true. Basically, you are true. I basically did SAP 5 and co certification, as I told you. Then I did my S4 HANA training, and unluckily that I failed first time paper in S4 HANA. So that's why I talked to your help. And the next, because all those are linked with modeling, and my desire was to go through these subjects. That's why I catch you.
Yeah, because it is very important that you should go from the beginning and into the depth. So directly, yes, if you jump on here, no problem. I can straight away develop this object there. But what happens is, it looks very difficult for you rather than you have to go step by step. That's why I was, if you want, I can actually, again, talk about all this, no problem. I want you to understand how we move from simple modeling into the, multidimensional modeling into the complex multidimensional modeling. So
Sir,
that is something that you have to understand because, yeah, please.
sir, honestly speaking, I would prefer to hear your recording again and read the book material, so it will make more effective instead that you repeat it again. What I perceive.
Exactly.
Ask from.
Exactly. That is what you should do. Exactly. That is what you should do. What you do is you can just follow it again and just go through this. And then I'm sure you will come up with some questions. You will come up with some doubts and some of the things you need to be clarified. So you just ask me. So
Yes,
that
sir.
once we clear, the same thing, believe me, the same thing we are going to implement in SAP HANA, but the terminology, the word will be changing. If you know these concepts, it's very easy with the help of GUI because I'm talking about the GUI HANA modeling. So you don't need to know much of the SPL also. It is just the process. You should know, what steps you have to follow to get to this complex structure. So because the tool will help you. Yeah.
Yes, sir. Basically, I worked as a financial analyst, and in Canada, I am teaching SAP FI and Co end user, end-to-end and BI end user and financial modeling in Excel. So I have little bit small experience in learning, and so once I will go through from your recording and material, then it will be more fruitful for me.
Please do that. Please do that. And Asma, is that clear what you asked me on this thing?
Yeah.
Yeah. So don't worry so much. Even if you find some difficulty on these things, it'll be you'll be clarifying all your things going forward. Because once I get to the actual things, slowly some of the things will be clarified. Some things looks like a little bit, tough, but that's okay. You can actually get to that. So let me just show you this tool. This is what I logged on to, remote computer right now. So let me just show a little bit of HANA Studio before even I jump onto HANA modeling, because the next topic that I have is here. Going on to HANA modeling. Maybe before that, I would switch on to the HANA architecture or other things also. We'll be doing all simultaneously. Let me just show you the tool right now. So you remember, right, we are going to work with the SAP HANA Studio. This is the main tool. So this tool, we're going to work more than 60% in this tool only. So this tool is basically an IDE, integrated development environment, Eclipse based. And this tool is having a set of tools, not just one thing. And this tool communicates with the HANA server using SQL and MDX. We'll talk about what is MDX, but just to give you a glimpse of MDX. MDX is nothing but multi-dimensional expressions, which is a long ways to communicate with the multi-dimensional objects. SQL is a long ways, structured query long ways you will use when you want to communicate with the databases, which are two-dimensional by nature. So SQL is used as a long ways, communication long ways to talk to the two-dimensional objects. But whereas multi-dimensional expressions, MDX, is also a proprietary language, is also a programming language. You normally try to use this when you want to talk to the multidimensional objects. So at the same time, SQL also can be used for multidimensional objects. This can be both, but this one is for the multidimensional objects. So the SAP HANA Studio talks to the SAP HANA server using these two. So internally, all this is set for us, and then we have this environment right now here. So I'm just clicking SAP HANA Studio just to show you a glimpse of it right now. Okay. So I have a system here. Let me log on to this first if I can. Okay, so this one is basically, you see here HANA database, HDB is HANA database. SAP HANA is a host actually. SAP HANA is a host here, and then 00 is an instance here. We are connected with the SAP HANA host with the 00 instance. Basically, the backup is for the administration. You don't bother about it. What we have to bother is the other 4 things that we have right now here in the system. Let us discuss a little bit about all these 3 things. And then you see here on the right side, this one is right now in the SAP HANA modeler perspective. Like I discussed before, you can bring this one into SAP HANA administration perspective, application development perspective, and other perspectives. How do you do that? You go here and change it, open perspective, and then you can get to the perspective that you're looking for. So you have all this, shortcut or quick view, for example. So delivery units and all this, we'll be talking about it going forward. So right now, just to say illustration, and you have the properties pane here. It's just like any other tool. It's just not so big deal with this tool. If you're operating the other tools, programming tools, this is the same thing. You have a job log here, and then you have a properties pane here. And on the other hand, you have SQL and these things. It'll come as and when we use it. But first thing, I want to explain the main 4 things that we have right now here. We have something called catalog, and we have something called content. We have something called provisioning, and then security. So what we do is inside the catalog, if you go inside, let me just unfilter this. Something is filtered right now, so that I just want to see what is there. See, if you go inside, you see something called schema. So the first thing is, let me put it like this so that you'll so we have HANA system. So we have this first, and then from here you are seeing, like, let's say the first one is catalog, right? Okay, and then from catalog it is going into the schema. Okay. On the other hand, so if you go to any schema, for example, I think they should be having my schemas. If they have it, you can filter like this also, whatever the schema you are looking at. If you type that, you will actually see the schema which has the names of whatever you're giving the filtering. If you go inside, the schema has all these objects, also the tables you have. So the column views, models, query sources, functions, indexes, procedures, all this. The main thing is you have the physical tables here. So the schema has physical objects. On the other hand, the next one, what you have is, yeah, please. So do you ask me, you want to ask some question? Hello? So on the other hand, because I want to bring exact difference, why I'm doing all this is, I will simplify such a way that you understand very easily what is going on, why they have to segregate like this, you know. After showing this, it is very easy for you to remember and understand. So the next one here you are seeing right now here is the content. Inside the content, probably let me just put it here. On the other hand, here you have the content. And from the content, you would go into the package. From the package, you would go into the views. You see, all these are packages. The symbol is for package. So inside the package, for example, if you click, you have views. So right now, it is very important that you understand these two first in the modeling. The other things we will see in the, data provisioning and data administration point. These two comes under modeling right now. The catalog and content. First of all, what is catalog? Catalog actually is a set of schemas. What is a schema? Schema is like your database stuff. It is a mini database. It qualifies all the rules that any database does. But it is mini in terms of size, in terms of its perspective. It is limited. So you have your own schema to keep all your physical, tables, physical procedures, physical. This is actually, the schema is nothing but a bundle of containers. You have this. So it is a room of containers, or for example, it is a building of containers which you have. So these containers are nothing but your tables, your physical tables, your master tables, your transaction tables, your procedures, which are residing there physically. When you want to use it, you can just call them or bring them and use it. On the other hand, you have something called content. The content is actually a set of packages. Package will have sub-packages also, set of sub-packages, but ultimately package will have information views, which are empty containers. So the package is nothing but the view, the modeling aspect that you will do inside the package. But how you relate these two? Actually, these two are connected such a way that, these two are internally connected, but we don't see that connection because you cannot make information views without having the physical tables, right? You would borrow the structure from the physical table, isn't it? The point is you are actually getting your structure from here to here. But there is no relationship between these two straight away. And the Asma left it. Any problem? You guys can hear me? Hello, Aruna, Kamran?
Yes, sir, I am here.
Okay. Well, we don't know. Maybe Asma has some problem. Or that's okay. So,
I'm here.
Aruna, yeah, you're there, right? Yeah, thank you. So, our intention is to actually make this information views as many as possible. For that, we are actually trying to study the data modeling. The subject is data modeling. So these information views obviously are related to the physical tables that are residing. So we would actually have to borrow this physical table structure here while making these information tables. But you see here there is no straightforward connection between these two. The system will have internally, which we don't see here in here. In here we don't see that. In here these two are separated. There is a line between these two. There's a line actually between these two. These two are completely separated, saying that all the database things are under their catalog because it is organized in the form of schemas. For example, the Kamran will have his own schema and Aruna will have your own schema. I have my own schema. I'll have my own set of tables. So I have my own database, or could be one schema or one part, one subdivision of the project, or could be anything. So because the schema qualifies all the rules that database does. It is a database. It is a mini database for you. So when you want to create the smallest portion of the database inside, you better create a schema first, and then you go for more number of schemas for you to have the bigger size of the database. So it's just the catalog is nothing but all the physical objects. The content is nothing but all your modeling artifacts. So this is how the structure. And then provisioning is nothing but your data migration tools, your data replication tools. So when you want to bring data from external sources into the HANA box, obviously it is going to be a provisioning. So the security also we will discuss in our next course. So I think the time is, the clock is ticking for you. It is very late for you probably. I'll end the session for now. So I hope you're following me what I'm trying to explain here.
Yes, and I will go through that again tomorrow before the session.
Yes.
So,
Yes.
and these slides are they are in the Dropbox, right?
Yes, everything is in the Dropbox.
Everything, whatever sir is teaching, that is in the Dropbox.
Yes, so
Correct.
I'll go through that, and if I have any question, then I will ask you tomorrow.
Aruna, are
Please.
you in Canada or in US?
I'm in US. I'm in New Jersey.
Oh, great. Okay. So are you doing work or only for getting the classes?
So I'm working.
Oh, right.
I work. So yeah, that is very. I work 7 days a week. So.
Yeah, then it's 11 o'clock for you. But the thing is, I personally teach over here, so it start from 11 till 9. So I do not bother late sitting.
Yeah, but when I have, like, I'm a single parent. I have a kid, so
Oh,
I drop him.
right.
I leave like 6:50 in the morning. I drop him
Oh,
in school, then I go to the work, and then from work I go to his school. I pick him up, and then we come back home.
yeah. Then right. Okay. To see what is the timing are better for you all guys. So I will be mutual compatible for the timing.
No, that is okay because I mean I'm okay with the time, but yes, and also Friday I will not be able to attend the session on Friday, so I will send an email to Veloursoft to send me keep a recording for me. But I'm letting you know also, Vera, that I will not be able to attend the session on Friday.
Okay. Sound good.
Okay, sir, then good night. Thank you.
Thank you,
You.
sir. Thank you,
Thank
sir.
you.
Great. Thanks.
Thank
Okay, thanks.
you.